Yes, good evening everyone. Welcome to my class. Yes, good evening. Yes, last class we discussed about few important topics based on the syllabus optics. Yes, today we will discuss few important topic based on the remaining 2-3 topics are there. I will finish this one today. Yes, good evening everyone once again. Can you hear me properly? I am using the headphone. Outside construction is going on. Too much of sound here. Okay. Last class, everyone so many are not there in the live class. At least everyone you listen the recorded class. Everyone at least saw the recorded videos, recorded class based on the topic optics part 5. This is the part 5. Then today I will finish part 6 remaining few concepts. Okay. Okay, shall we start the class? Yes. Last class, what we discussed, briefly I will explain, okay? Then, characteristic of a wave characteristic we learned. Then, how we will decide the characteristic of a wave? The characteristic of a wave, example here, Vibgayar, that is a white light. Here, mainly the color of the light, otherwise the color, it will be depends upon the wavelength. White light, it contains 7 colors. All the 7 colors we can differentiate based on the wavelength. That is the important thing you have to remember. Then here, red color, what is the wavelength? 800 nanometer. Violet, 400 nanometer. Red color, because of the more wavelength, it has less frequency. Frequency is nothing but number of oscillation per second. Otherwise, how many waves it will form per second. In the red color, per second, here only you can observe only less number of waves it will form. Therefore, the frequency it will be less compared to the violet per second. Okay, same time, here you can observe the number of waves formed per second, it will be more, therefore the frequency it will be more. Then here the frequency it will be inversely proportional to the time. Then here when we are considering the white light, we will use the formula V is equal to F lambda. Here V represent the speed, F means frequency, here lambda means wavelength. Then here when we consider the medium air or vacuum, then normally Vibgayar, because of the different wavelength, it will show the different color. But in the case of a air or vacuum, the speed of all the 7 colors, the speed it will be same, even though they are having the different wavelength. Okay, therefore at the when light travels in air or vacuum, it will not split into 7 different color, it will be remains as the same white light. Okay, this is the very important concept. Maybe in the exam they may ask why when white light travels in air or vacuum, why it will not split into different 7 colors? Because all the 7 colors light, they will travel with the same speed, even though they are having the different wavelength, they will travel with the same speed. That one you have to remember. This very important topic. That's why at least those who are listening today, at least once if I revise, easily you can recall. Okay, then based on this concept, today I will explain why few concept, okay, few applications I will explain. That's why I'm repeating once again. Those who are at least missed the last class, they can follow in this class easily. Next one, same white light when it travels in different medium like water, glass, oil, etc. These medium we will consider as a denser medium. Here, when light travels from rarer to denser medium, otherwise denser to rarer medium, then it will bend towards the normal and away from the normal, that we know, okay. Then here red color, because of the more wavelength, it will travel with the high speed. When white light, when it is travels in air, travels other than air, means water, glass, oil, etc., any other medium, then here the red color, because of the more wavelength, it will travels with high speed. Next one, violet, because of the less wavelength, it will travels with less speed. Then here, when white light, when it is entered from one medium to another medium, except air or vacuum, that one you have to remember in the mind. Then splitting up of white light, it will takes place into 7 different colors. Then this process we will consider as a dispersion. Then here you have to remember why the splitting up of white light it will takes place, because the speed of all the 7 colors, it will be not same. Already I given two best example here. Red is the color having more wavelength. Because of the more wavelength, it will travels with high speed. Then violet, that is the color, because of the less wavelength, it will travels with the less speed. Why I will take the example for red and violet always, means red is the extreme wavelength is very very high. Violet is the, that is also one more like a extreme, it has very less wavelength, okay. When you compare these two, then remaining whatever you have, the remaining colors, you can easily you can correlate with these two extreme cases, okay. Then here one more important thing, refractive index of any color, it will be inversely proportional to the speed of the light, otherwise speed of the color light, okay. When the speed of the light is more, then refractive index is less. When the speed of light is less, then refractive index is more, because they are inversely proportional to each other. Then refractive index of glass is 1.5, then refractive index of water is 1.33. Then here glass is more denser than water. Whose refractive index is more, then that one we will consider as a denser medium. Whose refractive index is less, means we will consider that is a rarer medium. Then one more important thing here, okay, refractive index, it will be directly proportional to bending. What is meant by bending of light? Here the refractive index of glass is more than the refractive index of water. Therefore it will mean that when light enter from glass to water, then bending in the case of a glass, it will be more. Otherwise bending of light in the glass medium is more compared to the water medium, because the refractive index of glass is more compared to refractive index of water. You have to remember this point also very very important, this one also very very important. If you know the concept, easily you can answer any question in the exam. Then next one, how frequency it will depend upon the color. Frequency remains unchanged when light enters another medium. This is also one more important thing. Frequency, it will be remain unchanged whether it will enters in another medium, maybe water, otherwise maybe glass. Okay, it will be the frequency of white light, otherwise other colors, it will be changed in the air, but in another medium like water and glass, it will not change. V is equal to f lambda. V is means speed, it will be changes in another medium. Then even wavelength also, you know, it will be differ in the Vib Gaya. All the 7 colors, they are having the different wavelength, that one you know. Then here frequency, it will be unchanged when Pratima, bn angle, bending angle, You know, you want the values, I will tell that one in the next class. Normally the bending value they will not ask how much the extension of bending angle only. Here I wrote only in the bending angle you can include even here. Bending angle you can include here. Yes. Angle of bending you can consider. Okay. Next one understood here. Then here also a frequency of violet light is maximum because the wavelength it will be wavelength it will be less wavelength it will be less no for violet. What is the wavelength? Here I wrote less wavelength, then why I wrote here more. See here frequency here uh, red light wavelength it will be more, then violet wavelength it will be less. Then here because of the less wavelength frequency it will be more maximum. Hmm? Then move to the next one. Yes. Okay. Next one, scattering of light. Scattering of light is nothing but, see, when white light enters to earth atmosphere, this is the earth atmosphere. In the earth atmosphere, you are having the small particles. When this white light hit the small particle, consider here this is the small particles, then this particle it will absorb the white light. First it will absorb, then it will scatter the light in the all the direction equally. That one we will consider as a scattering of light. First absorption of white light it will takes place by the particle, then later after absorbing it will start scattering in all the direction. Then violet scatter most because of the less wavelength, and then red scatter more because of the more wavelength. That one you have to remember. Then relay scattering, this is the law. Scattering it will be inversely proportional to 1 by lambda 4 wavelength. Okay, this everything we. Then in two important thing here, when scattering it will takes place, you can ask one question, what is the particle size? If the particles are very big, can scattering it will happen? Only I explained the earth atmosphere you are having only small particles, in that case the scattering it will happen. Here the particle size if it is less than the wavelength of light, then scattering it will be takes place. Second, if the particle size is more or equal to wavelength of light, then there is no scattering. There is no scattering here, but here you will not observe any scattering because all the 7 colors they will be equally scattering. You will get a white color here. Okay, when particle size is more than or equal to the wavelength of light, that is very important concept you have to remember. Then this everything I explained, dispersion of light, you know, this refraction also, this recombination, this also easy. Total internal reflection, this last class only I explained. Then here one more thing, last class where I stopped. See here in the rainbow you will get, when after the rain, which are the process it will occur here? Refraction it will occur, dispersion it will occur, even total internal reflection. All the three phenomenon it will occur, then only you can observe a rainbow after the rain. This also I explained detailedly in the last class. Okay, today I will explain few application based on the scattering of light. Very important, you have to remember. Okay, after this one more class I will take. I will give half an hour break. Last class only I informed. Now onwards I will take only physics. Almost Everyone are telling maths, all the portions are completed. Even sir also, Raman sir also, he told, ma'am, maths portions all it is completed by other sirs. Okay, I will concentrate now onwards only physics. My aim, at least at the end of this month, we will finish all the physics, all the portions. Then once maybe after the notification, we will start doing only MCQs, both in maths also, both in physics also, we will see. Okay, because in physics still 5 6 I have the chapters, I have to complete portions first, then after completion we will discuss the MCQ, both maths also, physics also. Okay, then next one, atmospheric refraction. The refraction by different layer of atmosphere is called atmospheric refraction. What is mean by atmospheric refraction? Means, already I told, in the earth you are having different layers. In different layers, how the refraction it will happen. Okay. Next, apparent flickering of object be placed behind a hot object or fire. This one, these are the few example the how atmospheric refraction it will happen. Then apparent flickering of object placed behind a hot object or fire. See, if you keep any object behind the fire or hot object, then that object it will appear to blink. Blink means it is appear to produce the light. Normally because of the this it will appear to produce, otherwise it will be flickering because of the process of refraction. Okay, then star near the origin appear slightly higher than their actual position. Everything I will explain in detail. First I will tell the example. Third one, advanced sunrise or sunset. Sunrise or delayed sunset. Why it will happen here. Then apparent flattering of sun disk, twinkling of stars, everything it will happen because of the atmospheric refraction. Let us study one by one in detail how it will occur. An object placed behind the fire or hot surface appear to be flicker when seen through the air. This is the first example here. The air above the hot surface become hot and rises. The space is occupied by cool air. The refractive index of hot air is less than the cool air. Here, see, assume this is the surface of the land. Here, assume you put fire here like this. Maybe fire is here. Then here, when the fire is there, then the air near the fire, otherwise near the hot region you can consider. Then here, the space is occupied. This one, consider the hot air. This one, the particles, they are far from the air. Maybe we will consider as a cool air, otherwise cool region you can consider. The air above the earth surface become hot, then it will rises up. This hot air, it does not contain any water droplets. Correct, no? Normally what will happen if you increase that if you increase the temperature of any object, what will happen? It will lose its water droplet, otherwise moist you can consider. Even moist is nothing but water vapor you can consider instead of droplet. Both also same. Instead of droplet you can consider even water vapor also, otherwise moist. Without moist it will form a hot air. Then the hot air it will move up towards the cool air. The refractive index of hot air is less than the refractive index of cool air. Here the refractive index of hot air is, it will be more compared to the refractive index of cool air. Okay, because the cool air it will be denser. Why it is denser cool air? Because it contain a water vapor. Correct, no? Why it is denser? Because it contains a water vapor. Because of this water vapor, the medium is denser. If the medium is denser, refractive index is more. See how they are related to one another. Then here, coming to the case of hot air, there is no water vapor, there is no water droplet. Then this medium is the rarer medium. Therefore, in the rarer medium, refractive index it will be refractive index what they are given. Hot air is less, refractive index is less here. In the cool air, the refractive index is more. But this one is the denser, this one is the rarer. The yes, less. The refractive index of hot air is less than the refractive index of cool air. Refractive index is less is nothing but rarer medium only. Here I wrote refractive index is more. No. Refractive index is less. Here the refractive index is less, therefore it is a rarer medium. Refractive index is more means that is a denser medium. So the physical condition of the medium are not constant due to changing refractive index of the medium. The light appear to be come from different directions. See here what will happen when you when you near to this surface, if any fire, otherwise if you keep any hot object, what will happen, this air when it will be in contact with the fire or hot region, what will happen, this air it will become hot, then it will move up. Okay, once again whatever you are having the cool air, it will come down, the hot air it will move up continuously. You can observe there will be a circulation of hot air, cool air, everything. The cool air it will comes down, because of this fire it will heat it up, again it will move. Therefore continuously there will be a change in the refractive index of the both the medium. Here the refractive index is not constant, it will be go on changing because of the cool air and hot air continuously they are circulating. Because of this change in refractive index in this medium, the due to changing in refractive index of the medium, the light appear to come from different direction, because the bending of light, otherwise refraction it will be takes place because of the multiple refraction you can consider. Refraction it will be not constant here, it will be go on changing. As a result, the any object near to the hot region or near to the fire, it will be appears like flickering is nothing but like twinkling of star is there, no, like that. The object it will be emitting its own light, it will appear to emitting, normally it will not emitting, but it will appear to it will show some lights. Okay, it result in fluctuation in apparent position of the object. For you will feel the object position it will be continuously changing, because the hot air and cool air continuously it will be circulating. Okay, next you will come to know, this is also very important thing. Star when seen near the origin appear to be slightly higher than the actual position due to atmospheric refraction. Normally when you see this one exactly at the origin, exactly or at the origin, see the star actually, the actual position of the star is this one. This is the apparent position of the star. The star it will be appear to little raised up. One simple example, see here, take one glass of water, put 1 rupee coin inside the glass. Then here when you observe the coin from the top of the water level, then you will feel the coin it will rise up. Normally the coin it will not rise up, but it will be appear to rise up. This why it will happen, because of the refraction of light. These are the very simple example, almost all we did in the class, correct now. The refractive index of earth atmosphere in general increases from top to bottom. How the refractive index, how it will be vary in the earth. See, consider this is the earth. I am explaining slowly because these are the very important concept. Definitely they will ask in the exam. This is the earth surface. Around the earth surface you are having the atmospheric layers you have like this. Okay. Then here what they are telling, the refractive index of earth atmosphere in general increases from top to bottom. See, as we move from, consider this is the top to bottom, the refractive index also it will be increases. Okay. Then so light coming from a star near the horizon has to travel from rarer to denser medium. It bends towards the normal. Already you know, when light rays, when it is travel from rarer to denser medium, it will bend towards the normal. Consider this is the refracting surface, this is the normal. If this is the incident light, if this is moving from rarer to denser, then this is the normal. This ray it will bend towards the normal, like this, towards the normal it will bend. This one normally it will bend towards the normal. When light ray, when it is moved from rarer to denser medium towards the normal, this is the normal, towards the normal it will bend. That is very very important. As a result, the star appear to higher. Here two important thing you have to remember here. Why? When you see the star at the point of origin, okay, the star it will be appear to little raised up. What is the reason? Means in the earth, your earth atmosphere, the refractive index it will be rises as we move from top to bottom. Okay. Then this change in the refractive index, that is one more thing. Then here when light enters from rarer to denser medium, then the incident ray, the refracted ray, it will bend towards the normal. This is the normal because of the these two reason. Okay, reason, the star it will appear to little raised up. Understood everyone? Are you following? If you have the doubt, you can ask me. Are you following? Anyone tell me? Yes. Still so much is there in the optics. Optic is the very big chapter, and also all the concept are interesting. It will be almost, it will be related to our daily life. Even I don't want to skip any single application also, because this is the very basic we have to know. That's why. Okay. Next one, advanced sunrise or sunset. Before, okay, we will feel the sun it will be set, otherwise the sun it will be rise compared to the actual timing. The sun appeared to 2 minutes earlier than actual sunrise, and the remain remains visible for about 2 minutes after the actual sunset. This is actually it will happen. Why? What is the reason? When the sun is below origin, okay, what will happen? The ray have to pass from rarer to denser medium. The ray it will bend towards the normal. This also uh, the reason it will be same. As a result, the sun appear to be higher than its actual position. Okay, because the sun rays it will be at the origin or below the origin, the light rays they will travel from rarer to denser medium. Again the bend, the light rate it will the light rays it will bend towards the normal. That is the reason. These are the very very important things. Definitely they will ask in the exam. Okay, multiple choice based on this concept only they will ask. Okay. Next one, the star appear brighter when more light from the star reaches our eye. The same star appear dull when less amount of light reaches our eye. Both this effect are responsible for twinkling of stars. What is mean by twinkling of stars? Because the star is a luminous body. What is mean by luminous body? Luminous body means the object which can emit their own light. Okay. Our body is not a luminous body. Luminous. Okay. See the spelling, luminous body. Our body is not a luminous body because we will not produce any light. Correct? No. Star is one of the important luminous body because it will emits its own light. Then why do, that's why in the night you can observe the star, it will twinkle, twinkling of star. Okay. Next, why do planets do not twinkle? Why the planets, why they will not twinkle? Because planets are non-luminous body. Luminous body is star because it will produce its own light. Here planet is not a non-luminous body, correct? No, it will not produce its own light. Very simple example. The planet are much closer to the earth and thus seen as extended source. If we consider a planet as a collection of a large number of point size source of light, the total variation in the amount of light entering the our eye from all the individual point size source will average out to zero, will nullify the twinkling effect. No need to write all those things. Only you have to remember why the stars, why they will twinkles. Here they are given the stars, they are very far from the earth. Therefore, whatever the rays they are produced from the stars, then it will take, it will be reaching the earth. Therefore, it will appear like the star is twinkling. But that is not the proper reason what they are given in the, here they are given in the some website. I took this answer. This also in the one way it will be correct, but more appropriate answer for these two questions, why the star they will twinkle, because they are all luminous body. Luminous body means they have, they can emit their own light. Here the planet, they will not be, they are not able to emit their own light, they are non-luminous. But whatever the condition here they are given, the planets they are not very close to earth because they will be far from the earth compared to the sun. So, sorry, compared to the star, what they are given the information, that is also correct. But main thing you have to remember this point. Next one, scattering effect, spreading of light in various direction by colloidal particles. What I am explained, that one you have to remember. Scattering means, yes, that is correct, spreading of light. But here one thing you have to remember here, when white light enters the atmosphere, then the particles it will absorb the white light, then it will get scattered in all the direction equally. Okay, first absorption, later scattering, that word you have to remember. Then scattering, amount of scattering is inversely proportional to wavelength. This is also very important thing you have to remember. 1 minute, I will drink water. Are you following everyone? If you have the doubt, you can ask me. Next one, Tyndall effect. What is meant by Tyndall effect? When light passes through the colloidal, its path becomes invisible. This is called as a Tyndall effect. What is meant by colloidal solution? Tell me any example for colloidal solution, because everything you studied in chemistry. Colloidal solution, true solution. Hmm? What is meant by colloidal solution? Give any one example here. Curd mixed with water, that is also colloidal solution. Example of colloidal solution, correct? No. Then chalk powder plus water. Yes. Here you can, what is meant by colloidal solution? If you mixed anything with water, otherwise not only water, if you mixed any two different solutions, okay, otherwise any two solid, liquid, any, okay, any matter, if you mixed matter you can consider in general, then here what is meant by colloidal solution means, in colloidal solution at least you can see the particles they will be continuously roaming inside the solution. You can observe curd, take curd, one spoon of curd mixed with water, still then you can see the curd particles, they will be roaming in water medium, correct? No, even chalk powder also, don't take salt in water, don't take here, consider here sugar in water, because that it will be dissolved, that is true solution, that is different case. Okay, here why you will observe the path of rays in the Tyndall effect, what is the reason? Here path of light become visible when light enters a dark and dusty room through a slit or ventilator. This one everyone we observed in our home. See, in the morning, okay, once you open, if your home door is exactly facing the sunrise, okay, sunrise, okay, then when you open little little, when you open little door also, like small space, even you can observe this one in window also, if you are having the gap between the door or window, then you will observe the light enters a dark dusty room through a slit, you can see the path of rays neatly. Then next one, path of light becomes visible when light passes through a denser canopy of tree in a forest. Consider this one very thick forest, even that thick forest, the light rays, it will not enters easily. Okay, only is the small portion in the forest, only the small like a slit. Okay, consider like a slit means only the small space. Within the small space, if light rays enters, then that effect we will consider as a Tyndall effect. Here, why, how we will observe in the colloidal solution means, when light rays, when it will hit the small particles here, okay, when it will hit, then it will come back because of the refraction. Then here you can observe the path of the light rays. Okay, this one I think everyone you observed in your home. Next one, the color of scattered line depends upon the size of scattering particles. Already I told, when you will observe the scattering, the particle size, if it is less than the wavelength of light, then only you can observe the scattering. If the particles are very fine, very small particles, they scatter mainly the blue color of light of shorter wavelength. If the consider, if the particles are very small, then here normally they will scatter only the blue color of light, because blue color it having the less wavelength of light. Okay, next, medium size particles scatter mainly red color because of the longer wavelength. Even large particles scatter all the color of light, is why appear to be white, correct? Now I told, if the particles, if they are bigger than the wavelength of light, then it will not, all the colors they will scatter equally, in that case you will get the white light. Wavelength of red light is about 1 by 1.8 times more than that of a blue light. That is one more important thing you have to remember. What I am explaining, no need to by heart, you have to remember the concept. If you are not able to follow one time, second time, but what are the important things I am explaining here, that one you have to recall, no need to by heart everything. Okay, why danger sign are made up of a red color? Normally danger sign, why they will use red color only? These are the very important application level questions, that's why I included question with answer, because if I provided in the PDF format, at least you can revise. Okay, a red is the least scattered color, yes, no, because of the more wavelength, the scattering it will be less. You know, the scattering is inversely proportional 1 divided by lambda 4. This is relay law, already I explained. Red color have the wavelength, it will be more, means the scattering it will be less. It is least scattered by fog and smoke, can be seen in the same color over a long distance, so danger sign are made in red color. This one you can observe, those who are in railway track or any region you can observe. Normally they will use the red color. Even red color, if you are far from the that station also, the red color you can observe. Even if you are there, if you are uh, from there for a longer distance also, you can observe the red color. Okay, because the scattering of red color it will be less. Next one, why the color of sky appears blue on a clear day. You can observe why the sky it will be appear only blue, not like other colors. Normally in the Vibgayar we are having the seven different colors. Why the sky it will appears only blue color? Why it will not appear any other color? What is the reason? Let us discuss here. Next, the upper layer of atmosphere contain very fine particles of water vapor and gases. These particles are more effective in scattering of light of shorter wavelength, mainly blue, than larger wavelength. So the sky appear to be blue. Consider this is the earth. In the earth you are having the different atmosphere. Then consider this is the sun. From the sun rays they are coming. Then once they enter the earth atmosphere, you can observe the scattering of light it will takes place. Normally you are having Vibgayar, seven different colors you have. Then here see, when this light rays, when it will hit the dust particles, the scattering it will takes place. Here you can observe violet, indigo, blue. Here violet, indigo, blue. These three colors. Okay, violet, indigo, blue. First three colors, because of the shorter wavelength, they will scatter more. Because of this relay law, those who are having the less wavelength, they will scatter more. Correct? No, according to this formula. Here, first three colors like violet, indigo, blue, because of the less wavelength, they will get scatter. Scattering it will be more scattering. Correct? No, because of the more scattering of violet, indigo, blue, all the three if they merge, then the sky it will appears blue in color. Understood? Why the sky it will appear blue? Because normally the scattering of violet, indigo, blue color, because of the small wavelength it will takes place. Okay. Next, very important thing you will learn here. How does the sky appear to be an astronaut in the space or to a passenger of jet plane flying at a high altitude? Same sky for astronauts, it will appear black. See, already I explained the sky, it will appear blue for us, those who are standing on the earth. He will, okay. Then we are on the earth. If you see the skies, for us it will appear blue because violet, blue, indigo, because of the less wavelength, the scattering it will be more, it will appear blue. But astronauts, where they will be on the universe. Where they will be on the universe. Okay, in from the universe they are watching the sky. For them it will appear black. What is the reason? Because in the universe we don't have any atmosphere, we don't have air, we don't have any atmosphere. Vacuum, no atmosphere, because it has only vacuum means we don't have any atmosphere. Because of no atmosphere, then no scattering of light it will be takes place. If atmosphere is not there only, means how you will get the dust particles? If there is no particles for scattering of light, then there is no scattering of light. There is no even one dust particles also not there in the universe, then no atmosphere, then how scattering it will happen? Therefore for astronauts, same sky it will appear black, because these are the few, it will be look like simple, but you have to know scientifically what is the reason. Earth, again for from the same astronauts, Earth it will appear blue. Atmospheric blue light will scatter. Here also blue Vibgayar, if you consider Vibgayar, blue is having the color having less wavelength. Less wavelength means scattering it will be more. When the scattering it will be more, then Earth it will appear blue. Because why? Because the Earth you can observe around the Earth you will feel the atmosphere is there. Because of the Earth atmosphere for astronauts it will appear. How does the sky appear to be astronauts in the space or passenger? Okay. This is not from the astronauts. This Earth, what we explained, this is not from the astronauts. This is actually from outside how the Earth it will appear. It will appear blue. Then what about sun? It will appear white. All colors they will scatter equally. Scattering of all the colors they will take place equally. Okay. Sun from astronauts the sun it will appear white. Why it will appear white? Because all the colors equally they will get scattered. That's why it will appear light white, not light, white. Okay, understood everyone? From astronauts the Earth it will appear blue because the blue color, because of the less wavelength it will scatter more. The sky it will appear black because no atmosphere, no scattering of light. Sun, all the light rays they will scatter equally, therefore the sun it will appear white. Next important thing, why clouds appear white? Already we learned the sky it will appear blue. Same clouds they will be present in the sky only. Where they will be clouds, where they are situated, they will be inside, they will be in the sky. But clouds, why they will appear white color? The clouds are formed by water droplets here. The cloud particles are more, particle size of clouds is more compared to the wavelength of light. Therefore all the colors they will scatter equally. Here there is no differentiation of scattering. All the colors they will appear to scatter equally. Therefore the cloud they will appear white in color. Understood everyone? Next, last one. I think this is the last. Okay. Last important concept, otherwise the application of scattering. Why color of sun appear to red during sunrise or sunset? Why the color of sun, why it will appear as a red during the sunrise or sunset? What is the reason? Here during sunrise or sunset the position of the sun it will be in this angle towards the earth. Then here during sunrise or sunset, we are talking about only sunrise or sunset. Okay. Then light has to travel for a longer distance. Then here most of the Vibgayar, I will write here Vibgayar. Then most of the violet, indigo, blue scatter most of VIB is lost. Normally because of the less wavelength these colors they will scatter more, we know. But once they scattered, because at the time of sunrise or sunset you can observe there is a large distance between the sun and the earth. This is in the case of sunrise or sunset. There will be a large distance, otherwise the distance it will be more. Okay. Therefore, even though the violet, indigo, blue they will scatter most. One, because they will scatter means they will spread into different direction like this. Scattering means spreading of light in different direction. Okay. Therefore all the violet, indigo, blue for scattering they will lose all their colors. Whatever you have remaining you have violet, orange, red. At the end you will leave only red color. All these remaining rays, they will scatter most up to reaching the earth. They will get scattered in the different direction. Then which one is remaining? Only the red. YOR. Yellow, orange, red. Almost these three colors together, it will form a red color. Inner atmosphere contains only red, orange, yellow colors. That's why during sunrise or sunset, the sun, it will appear red in color. Understood? Understood? This also very important thing, because even though violet, indigo, blue, they will scatter most. Okay. Then here, because the sun is far from the earth during sunrise or sunset, this scattering because of the large distance, they will get scattered in different direction. Only what is remaining? These three, violet, orange, red, it will be remaining. But coming to one important thing, at the noon. At the noon means 12 p.m. exactly. Okay, at the noon means 12 to 1 p.m. The sun, exactly it will be on the top of the earth. Correct? No, exactly consider at least exactly 90 degree. In this case, you can observe the distance between the sun and earth. It will be little reduced compared to the sunrise or sunset. Light travels shorter distance, all the colors scatter equally. Then at the noon, okay, at 12 o'clock or 1 o'clock, this sun, it will be appear white in color. Understood? These are the few important application you have to remember. See, during sunrise or sunset, why it will appear red color means remaining colors, they will scatter most, only at the end the red it will be remaining. But at the noon, because of the shortest distance between the sun and the earth, all the colors what we have in the Vibgayar, all the colors, they will get scattered equally. You can observe. Sorry, noon, I wrote moon. Okay, noon. At noon, not moon. Noon. At 12 to 1 p.m. I wrote now here. Okay. At noon, sorry. Here I wrote the timing, no, I not observed the word. Okay. At exactly 12 to 1 o'clock. Then here, all the light travels shorter distance, all the colors scatter equally. Yes, Pratibha. Correct. Understood? Everyone up to here what I explained today. These are the few important things, important application of scattering of light. Maybe this one they may ask in the exam for the astronauts, why the sun it will appear white color, then why earth it will appear blue, why the clouds they will appear white in color, why the sky is blue. Everything I explained detail today. If they ask any question based on this scattering of light, almost everything it will be finished. Okay, understood everyone? Any doubt you have here? Very interesting, no, this one? Still so much is there, don't worry. Even I am not completed even 50% of 50 percentage of optics I have to complete. Then what his name, someone has mailed me, ma'am, explain myopia, then hypermetropia, that one in detail. What is his name? Renuka? No, I don't know, I forgot the name. Okay, that's why next class I will explain. That's eye defects are there, no, eye defect, why it will happen, what is the cause, then how we correct it, how we have to correct everything. Because two questions he included two questions also. One question we discussed in the class based on the power. Okay, that's why I will take one more topic based on that one. Now the time is 5 o'clock. Shall I take one more class at 5:30? I will give half an hour break, at least 5:30 to 6:30. I can complete the portions one more. Then tomorrow, if I have the time, I will take the class. Sorry, from last Saturday I'm not able to take one more class because suddenly Saturday no some guest came to my home. If the guests are there, then I'm not able to take the live classes. That's why Saturday I missed the class. I'm planning to take the class at Sunday, but Sunday I don't know how many you are free. Normally so many you will not attend at the Sunday. That's why even Sunday also I cancelled. Monday you are having the general papers. Okay, today is my class only. That's why I will take one more class at exactly 5:30. Okay. Shall we meet exactly 5:30? One more class 5:30 to 6:30. Then now onwards I will take only physics because I have to complete physics portions only. That's why. Okay. Okay. Bye everyone. Take care. If you have the doubt, you can ask me. This notes, even this, it contains optic 5 and 6, both the notes also. I even ma'am is asking, ma'am give optic 5 notes. Then I told her few concept I have to explain in scattering. I explained, I will send the notes, I told her. Then after the class I am sending the notes. Okay. Okay, bye everyone. We will meet once again exactly at 5:30. Okay.